And we're going to talk about two categories of problems that people can find a little bit tricky. These are set problems and sequence problems, and we'll start with set problems. Some word problems concern sets and members of sets. The topic of sets overall is potentially very complicated because humans can belong to all kinds of sets at once. We can ask a person, what's your gender? What's your native language? What's your socioeconomic class? What's your favorite flavor of ice cream? What is your eye color? What is your hair color? Etc., etc. These are all sets into which we can put people. And so one person could conceivably be in dozens, even hundreds of possible sets. Fortunately, the test focuses on a few relatively simple scenarios. The first set scenario, the easiest, is one in which there are two groups, and each member of the collection may belong to either group individually, or to both groups, or to neither. For example, at a high school, the two groups might be on the baseball team and in the band. So some students, the athletic students, will just be on the baseball team. The musical students will just be in the band. There may be some students who are both athletic and musical, so they're going to be in both. And then there may be some students who are not athletically inclined or musically inclined, and they're going to be on neither team. So that's an example. This scenario is often represented by a Venn diagram. A basic Venn diagram consists of two overlapping circles inside a rectangle. Occasionally, the test will actually give this diagram as part of the question, but if not, students often find it helpful to sketch one for themselves. Elements inside one circle are in one of the groups, and elements in the overlap section are in both groups. Notice that this diagram consists of four distinct regions. So here the regions are colored. So region A, this is the region inside the left circle and not inside the right circle. So region A is not the whole circle. Region A is just the red part. It's the whole circle minus the overlap region. That is region A. Region B is the overlap region. That's the part, the folks that are inside both groups. It's inside both circles. Region C is like region A. It's inside the right circle, not inside the left circle. So again, that's not the whole circle. It's the circle minus the overlap part. That's region C. And then region D is the white region outside, and these are all the people who are not members of either group. Notice that if each one of these equals numbers, how many in A, how many in B, how many in C, how many in D, if we add those up, it would equal the total number of people in this population. Notice that the way information is given can be very tricky. Let's just say that the left circle is in the band and the right circle is on the baseball team, for the sake of argument. If the question says 35 students are in the band, well, what does that mean? They're giving us how many people are in that entire left circle. Well, that entire left circle is two regions, so they're telling us that A plus B equals 35. They're not giving us a single region there. They're giving us the sum of two regions. But in what might seem the same, this wording is actually very different. If the question says 35 students are in the band only, well, now we're talking about the people who are only in the band who are not on the baseball team. And this means that just A by itself equals 35. So in this second statement, they're actually giving us a single region, not the sum of two regions. What this means is that it's very important to read the exact wording in these questions very carefully, because a single word can make a difference, and making this difference, it will totally change your calculations. So you have to be very careful in reading these questions. A typical sets question of this variety almost always would give the size of the whole group, which would be equal to the sum of these four regions. The other information will provide some other regions from addition or subtraction. We can determine the rest. Sometimes, as we'll see, we also have to do a bit of algebra to solve. Here's a very simple practice question. Of the 100 students in a school, so that's the total population, 60 are in the band, 35 are on the baseball team. If 25 students are in neither the band or on the baseball team, how many are in both? So pause the video, and then we'll talk about this. Okay, so we can set up our Venn diagram, and we know that that 60 and that 35, both of those are sums of regions. Those are not individual regions. So the 60 is A plus B, everyone in the left circle. The 35 is B plus C, everyone in the right circle. They are good enough to give us D equals 25, the folks who are not on either. Well, let's think about this. There are 100 people in the school. 25 of them are in that white region. So that means that 100 minus 25, 75 must be somewhere in those two circles. So A plus B plus C has to add up to 75. All right. So now what I'm going to do, I'm just going to add those two equations at the top. Combine the algebra, combine the numbers, I get A plus 2B plus C equals 95. Notice this is almost identical to the equation A plus B plus C equals 75. There's just a second factor of B, and the number is different. So all I'm going to do is subtract A plus B plus C equals 75, subtract that from the bottom equation, and that will leave me with B equals 20. And that's the answer. Here's a harder question. This is a question typical of what you might see on the test. So pause the video and then we'll talk about this. At a certain school of 200 students, the students can study French, Spanish, both, or neither. Just as many study neither as study both. That's interesting. 1/4 of those who study Spanish also study French. The total number who study French is 10 fewer than those who study Spanish only. How many students study French only? Okay, well this is complicated and definitely there's going to be some algebra involved. So let's say in our Venn diagram that the left circle is French, the right circle is Spanish. So first of all, they're very good to tell us just as many study neither as both. So in other words, B equals D. We know that. 1/4 of those who study Spanish also study French. So if we consider the people that study Spanish and French, the people who are in the both region, the overlap region, then 4 times that amount is the total number of people who study Spanish. So in other words, B plus C equals 4B. And we can simplify this by subtracting B, and we get C equals 3B. All right, so that's another equation. Now we have this, the total number who study French, so that would be A plus B, equals 10 fewer than those who study Spanish only. Well, Spanish only is C. 10 fewer than Spanish only would C minus 10. So A plus B equals C minus 10. And I'm going to sub in that C equals 3B. And then I get this expression for A. Well, notice now that I've written D, C, and A all in terms of B. And so that means that I could go back to my original equation, the sum equation, A plus B plus C plus D equals 200, and write everything in terms of B. So I'm just going to sub in all the expressions I have, express everything in terms of B. So I have one equation with one variable. Collect the terms and simplify, divide by 7. I get B equals 30. Once I have B equals 30, what I'm looking for is the students who study French only, which is region A. So I'm just now going to solve for A by plugging this in, and I get A equals 50. That's the answer. Venn diagrams can be very helpful in problems with two overlapping sets. The problem may give a Venn diagram, but if it doesn't, one is often helpful for solving this kind of question. You can draw one on the scrap paper and it can really speed up your calculations. Remember to be careful in interpreting wording. All in X includes those in Y as well, but all those in X only excludes those in the other group. So you have to read the wording very carefully and pay attention to the use of the word only.